Hello everyone, welcome to the course on hybrid electrical vehicles developed by Jawaharlal Nehru Technological University, Kakinada, supported by Andhra Pradesh State Council of Higher Education. I am Dr. Gudipudi Nageswara Rao, Professor, Electrical and Electronics Engineering Department at Lucky Reddy Balareddy College of Engineering, Mailavaram. Electric drive systems. The primary electric drive train components for fuel cell vehicles are the same as those for any electric vehicles: traction motors, power electrons, and batteries. Electric drive components require their own sets of auxiliaries and management systems for control and cooling of the equipment. A fuel cell vehicle may have a hybrid powertrain in which the fuel cell is sized at less than the vehicle's peak power requirement, and additional power is supplied from an electricity storage device such as a high power battery or ultra capacitor. Although a hybrid powertrain is more complex than one using a fuel cell alone, it offers advantages of regenerative braking, which helps vehicle efficiency and the availability of greater power for startup and auxiliary loads. Hybridization also would have an economic advantage if the cost of the peak power from the electricity storage device is less than that of meeting the power peak requirements with a fuel cell alone. In this video, I am going to explain the electric vehicle drivetrain. The content in this one is what is the transmission configuration, what are the components of drivetrain, and what are the latest advanced technologies available in this electrical vehicle drivetrain. This slide shows the general configuration of an electric vehicle. A conventional engine-driven vehicle uses its engine to translate the fuel energy into the shaft power, directing most of this power through the device train to turn the vehicles. Much of the heat generated by the combustion cannot be used for work and is wasted, both because heat engines have the theoretical efficiency limit. Moreover, it is impossible to reach the time theoretical efficiency limit because some heat is lost through cylinder walls before it can do work. Some fuel is burned at less than the highest power possible pressure, and fuel is also burned while the engine is experienced negative load during braking or when the vehicle is coasting or at a stop with the engine idling. There are many possible electric vehicle configurations due to variations in electric propulsion and energy sources. Based on these variations, 6 alternatives are possible. In this figure, a single EM configuration with a gearbox clutch is shown in this figure. It consists of an EM, a clutch, gearbox, and the differential. The clutch enables the connection or disconnection of the power flow from electrical machine to the wheels. The gear consists of a set of the gears with the different gear ratios. Box and clutch is shown in this figure. The advantage of this configuration is that the weight of the transmission is reduced. The electric vehicle drivetrain alternatives based on the power source configuration. Besides the variations in the electric propulsion, there are other electrical vehicle configurations due to variations in energy sources. There are 5 configurations possible. They are: configuration 1. It is a simple battery powered configuration. The battery may be distributed around the vehicle, packed together at the vehicle back or located beneath the vehicle chassis. Configuration 2. Instead of the two batteries, this design uses two different batteries. One battery is optimized for high specific energy and the other for high specific power. Configuration 3. The battery is an energy storage device, whereas the fuel cell is an energy generation device from air. Configuration 4. Rather than storing it as a compressed gas, a liquid or a metal hydride, hydrogen can be generated on board using liquid fuel such as a methanol. In this case, a mini reformer is installed in the electric vehicle to produce necessary hydrogen gas for the fuel cell. Configuration 5. In fuel cell, the battery combination, the battery is selected to provide high specific power and high energy respectively. In this configuration, a battery and supercapacitor combination is used an energy source. This slide shows the electric vehicle drivetrains, ensuring effective power transmission at high torque through manufacturing solutions designed for the requirements of electric vehicle drivetrain systems. Compared to the development process for traditional combustion engine vehicles, e-mobility is driving sustainable change in the way of manufacturer approach drivetrain design, where previously 6-speed manual or 8-speed automatic transmissions were standard in the automotive world. State of the art of electric vehicles use different kinds of the automatic transmissions such as two-stage greater drives, integrated stepped planetary gear drives or continuously variable transmissions, and also known as shiftless transmission to operate at optimum efficiency. Often, electric motors, power electronics and drivetrain share a single housing, reducing the overall number of components in the powertrain and lowering the overall weight of the system. In the battery electric vehicles, this integrated unit may directly power a combined electric axle drive. In hybrid electrical vehicles, various transmission configurations are possible depending on how the manufacturers intended the electric motor and combustion engine to interact with each other. While many operating principles for electric vehicles drivetrains differ from their counterparts in combination or combustion engine vehicles, on the components level, there are actually many similarities in the design and manufacturing process required. The key components like straight gears, helical gears, and housings are common to both types of the drivetrain. The main challenges in the specializing such components for electric vehicle drivetrains are to deal with the higher torque and speed of the rotation that can be realized with electric motors, the tolerances involved in the precision manufacturing of the transmission components like straight and helical gears or planetary gear drive systems are typically tighter for electric vehicle components. The surface finish of gears also gains new importance as the noise emission of the drivetrain is critical in electrical vehicles due to the silent electrical motor. Hexagon has considerably experience in the development of the powertrain components in both automotive and aerospace sectors and is well placed to the support manufacturers throughout the development of the electric vehicles drivetrains. And simulation solutions enable manufacturers to optimize the gear and bearing design, model development and model durability, simulate lubrication efficiency and access noise emissions before vehicles go into the development. The production software solutions both validate production process and ensure precision manufacturers of tight tolerance transmission parts, while Our ultra high accuracy measurement systems are specified for inspection and quality assurance of critical parts like gears, shafts, and chassis.